Welcome to Episode 38, System and Information Integrity Part 2, Flaw Remediation and Protection Patterns. Our goal is to build and prove the backbone that keeps systems trustworthy when defects and threats are constant. Flaw remediation is the daily engine that turns discovery into fixes and fixes into verified stability. It connects intake, triage, testing, deployment, and evidence so leaders see progress and responders stay aligned. Backbone first. When the program is built as a steady workflow, clear inputs, named owners, rehearsed steps, measurable outcomes, integrity stops being a hope and becomes a habit that holds under pressure and change. Building on that foundation, the first job is to capture issues from every credible intake source, vendor advisories, vulnerability scanners, and internally reported bugs. Each source brings a different signal, so the intake process must record where an item came from, what it affects, and how urgent it might be. Alerts without context waste time. Context without capture gets lost. Imagine a developer finding a repeatable crash while a scanner flags an outdated library and a vendor issues a critical advisory. Intake should accept all three with equal clarity. Keep it simple. A lightweight intake form with required fields and links beats long narratives that hide the facts and slow the queue. From there, normalizing identifiers, versions, and affected assets prevents duplication and confusion. Different sources may reference the same flaw with different names, so the register should map them to one canonical entry tied to precise versions and systems. Normalization links a library version to the services that include it, the hosts that run it, and the owners who can change it. For example, a single cryptography package might appear across 4 applications. Mapping pulls those appearances into one action plan instead of 4 scattered tickets. Use stable keys. When items share a common identity, reports become accurate, dashboards stay clean, and progress is visible. Extending that structure, triage needs clear scoring and window targets that everyone understands. Scoring weighs exploitability, exposure, and potential impact while considering available compensations, and window targets name the time to fix by class. A critical remote flaw on an internet service might require same-day action, while a low-risk internal issue gets a longer window. Publish the rules and keep them small enough to remember. For instance, tie targets to category and surface, then adjust when a business calendar or change freeze demands it. Clarity reduces debate. People move faster when the expectations are written, bounded, and fair. From there, stage, test, and rollback rehearsals turn intention into safe motion. Staging pushes candidate fixes into environments that mirror production closely enough to reveal surprises. Testing validates both the flaw's closure and the system's continued function, including logging and monitoring. Rollback should be a practiced step, not a desperate hope, and teams should rehearse it before high-risk changes. Imagine proving a database patch in staging, capturing performance baselines, and then reversing the change twice to confirm the path back. Practice lowers fear. When teams know the way out, they deploy with care and speed instead of hesitation. Continuing the disciplined path, isolation steps, compensating measures, and waiver criteria keep risk controlled while fixes proceed. Isolation narrows exposure through segmentation, throttling, or access rules when immediate remediation is not possible. Compensating measures add guardrails such as additional monitoring, stricter authentication, or temporary feature flags. Waivers document the reason a fix cannot meet the target and the conditions that end the waiver. Write waivers short and specific. For example, defer a firmware update until a maintenance window, but require increased logging and a block on new enrollments until completion. Controlled exceptions protect trust while work continues. Building broader coverage, endpoint detection and response brings visibility and containment to the last mile. These tools watch for suspicious behavior, record useful traces, and can isolate a system quickly without cutting the whole network. Coverage should reflect risk. Critical roles and high-value data need deeper sensors and faster actions. Imagine a workstation used for finance showing unusual script execution. Isolation buys time for investigation without losing the evidence. Tune alerts to the environment. Noise erodes confidence, but signal tied to action builds speed, learning, and reliable follow-through during crowded days and tense nights alike. From there, layered protection across email, web, and macro execution blocks the most common entry paths. Email controls filter malicious attachments and links. Web controls restrict risky destinations. Macro policies prevent unexpected code from running inside documents. These layers reinforce each other, and each should generate logs that connect to investigations and training. For example, when macros are allowed for a specific team, signed templates and limited sources reduce surprises. People need help. Simple prompts that explain why something was blocked turn frustration into understanding and reduce workarounds that weaken safeguards. Extending execution control, application allow listing, and related patterns prevent unapproved code from running at all. Instead of chasing every bad file, allow listing defines what is trusted and refuses the rest by default. Modern approaches use signed publishers, known hashes, and rule sets that adapt by role or group. Start with high-risk zones, measure user impact, and expand carefully. For instance, a build server should run only the compilers, agents, and scripts that are documented and signed. Fewer paths mean fewer surprises. When the default stance is no unless proven, integrity becomes the normal state, not the exception. From there, data integrity checks and signatures ensure that what systems store and move arrives unaltered. Checksums detect accidental corruption, while cryptographic signatures prove authenticity end-to-end. Apply them to files, messages, and backups so restoration relies on more than hope. Imagine verifying a nightly backup with signatures before declaring it ready. During an incident, restoration starts confident rather than blind. Keep verification visible. Dashboards showing match rates and failures give early warning, and tickets tied to mismatches ensure someone owns the fix. Truth is testable. Make it automatic and regular. Building on trust, update channels must be both trusted and verified so that patches themselves do not become new risks. Only accept updates from authenticated sources. Validate signatures, and pin expected versions where possible. For internally built software, sign artifacts in the pipeline and verify at deployment before anything runs. Think of it as a chain of custody from source to service. If a step fails validation, block the update and alert both owners and security. A clean path matters. When the path is sound, speed follows, because people stop second-guessing whether the remedy is worse than the problem. From there, exceptions must be documented with expirations, so temporary choices do not become permanent weakness. An exception entry should state the reason, the compensations in place, the owner, and the date it ends. Automate reminders and escalate overdue items to decision-makers who can fund or force closure. Imagine granting a 90-day exception for a legacy driver while a replacement is sourced, with monthly checks that confirm compensations still hold. Time limits focus attention. Without them, exceptions fade into the background and quietly raise exposure long after anyone remembers why they started. Extending outside the walls, provider inheritance must be validated and gaps addressed with named actions. Providers may deliver patching, malware scanning, or signature validation as part of their service, but those claims need evidence and alignment with your targets. Ask for reports, test with your own checks, and record results in the same register you use internally. When gaps appear, plan compensations or negotiate changes with dates and owners. Shared responsibility is shared work. Clarity here prevents finger-pointing during incidents and keeps the combined posture honest and defensible. In closing, protection patterns matter because they produce measurable outcomes that leaders can see and teams can prove. The remediation backbone turns flaws into fixes with evidence at every step, while layered defenses reduce the chance that a single miss becomes a major event. Measure what moves: time to triage, time to deploy, rollback success, exception aging, and signature match rates. Results speak. When numbers improve and incidents shrink, integrity is no longer a claim. It is the way your organization works. One verified change and one documented protection at a time. Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.